from previous lecture, we know what is a describing function. Describing function is a ratio of magnitude and phase angle of the fundamental component of output to the magnitude and phase angle of input. From the previous class, we find out the describing function for saturation. Today, we are going to find out the describing function of ideal relay. Ideal relay is also known as on-off nonlinearity or two-position nonlinearity. This is the basic diagram of relay. Relay is used in mainly power system, and this is the characteristics of relay, output characteristics. As we apply a sinusoidal input and we get a square wave output. So, if the input is x equals to capital X sin omega t, then E0 means the output for 0 to omega t is 0 to pi is capital Y, and when omega t lies between pi to 2 pi, it is minus y. From here we can find out A1, which is nothing but 0, and B1. Then we get the describing function GD j omega, which is nothing but under root of A1 square plus B1 square by x at an angle tan inverse A1 by B1. So here the GD j omega is nothing but 4y by pi x at an angle 0 degree. Next, we are going to find out the describing function of relay with dead zone. Actually, this is a practical relay. So, if we give a sinusoidal input, we get an output which is delayed by an angle alpha. Okay, so this is the dead zone position. This position is dead zone. This position is going to dead zone. After that, the relay works, and this point is known as a dropping point, and this position is known as a drop out point. Okay, then the maximum amplitude of input voltage is capital X, and the output E0 is equals to 0 when omega t belongs to 0 to alpha, equals to capital Y when omega t lies between alpha to pi minus alpha, again 0 when omega t lies between pi minus alpha to pi plus alpha, equals to minus y when omega t lies between pi plus alpha to 2 pi minus alpha, and again 0 when omega t lies between 2 pi minus alpha to 2 pi. From here, due to symmetry, it is due to odd symmetry, it is find that A1 is nothing but 0, and we calculate the B1, which is 4y by pi cos of alpha. So here we have to find out the value of cos alpha. From the figure, we see that omega t is equals to alpha and small x is equals to nothing but d by 2. So that is equals to against x of capital X sin alpha. From here we get sin alpha equals to d by 2x. So from the formula sin square alpha plus cos square alpha equals to 1, we get the value of cos alpha, and this value of cos alpha we put in the equation of B1, and then we get the final value of describing function, which is nothing but 4y by pi under root of 1 minus d square by 4x square at an angle 0 degree. Next, we are going to discuss about the relay or on-off nonlinearities with hysteresis. So, from here we at first draw the diagram, and we see that the input xt is nothing but x sin omega t, and this is the value of output, and the length of hysteresis is nothing but small h, means h is a dead zone of the on-off nonlinearity with hysteresis. So yt, what is the value of yt? Yt is equals to capital M for omega t lies between omega t1 and pi plus omega t1 from, or we can say that the time t lies between t1 and pi by omega plus t1 and equals to minus m for t lies between pi by omega plus t1 to 2 pi by omega plus t1. Further, we see that there is also a term comes y1t, which is nothing but fundamental harmonic component of output yt. Clearly, what happened? Now, the output is a square wave, but it lags the input by omega t equals to minus sine inverse h by x. As the output has an odd symmetry, so its fundamental term contains only the sine wave. That's why a0 is equals to 0, a1 is equals to 0, and we find the value of b1, which is nothing but 4 pi. Therefore, the describing function, actually this is nothing but 4m by pi. There is a mistake. This is 4m by pi. So, the describing function of the on-off nonlinearity with hysteresis becomes 4m by pi x at an angle minus sine inverse h by x. Here, there is another notation for describing function, which is also denoted by n of x. Next, we are going to find out the describing function of for the combination of dead zone and saturation. So, this is a dead zone. After that, the saturation characteristics occurs, and this is, we give the input. So, this point is denoted as alpha. This intersection is denoted by beta, and the sine, we know that the maximum value of sine wave occurs at pi by 2. And again, this is pi minus beta, pi minus alpha, and then pi. So, the input x equals to capital X sin omega t, and y, this is the output waveform. So, y is equals to 0 during 0 omega t 0 to alpha, equals to k into x minus d by y when omega t lies between alpha to beta, k into s minus d by 2 when omega t lies between beta to pi minus beta, k into x minus d by 2 means this portion when omega t pi minus beta to pi minus alpha, equals to 0 when omega t lies between pi minus alpha to pi. So from here, this is also a odd symmetry. So we get after calculation that a1 is nothing but 0. But you have to do the calculation in your exam. And then we have to find out the b1, and we get the value of v1 using integration, this value. So when we know that the input x equals to capital X sin omega t, and when omega t is equals to alpha, then d by 2 is capital X sin alpha. What is d by 2? This is d by 2. This is total d. So d by 2 is nothing but x sin alpha, or sin alpha is nothing but d by 2x, and omega t is beta. Capital S is equals to x sin beta. This x sin beta is nothing but capital S. So from here we get the value of sine beta. Put these two values of sine alpha and sine beta in equation 1 and we get the final value of beta 1, which is nothing but this term kx by pi into 2 into beta minus alpha plus sine 2 beta minus sine 2 alpha. So from here we get the value of describing function g d j omega, which is nothing but b1 by x at an angle 0 degree. And then we put the value of b1 here and we get the final result. Again there are some three conditions. When small x less than capital D by 2 and alpha equals to beta equals to pi by 2, then g d j omega becomes 0. When x lies between lies between d by 2 to x to s, then the value of g d j omega is 1 minus 2 by pi into alpha plus sine alpha cos alpha into k. And when capital X is greater than s, then the value becomes k by 2 into beta minus alpha plus 2 plus sine 2 beta minus sine 2 alpha. So these are the basic concepts. Okay, then we are going to discuss about the describing function of backlash. So at first we are going to describe about what is backlash. So the figure 1 shows the physical model of backlash. Here there is a input member and another is a output member. Here the input member is driven by a forward from the position shown in figure 1 or A, and when there is no movement, so no output motion takes place until the input member travels a distance h. If there is input, until there is no movement of the input member to till h, there is no movement in the output members. This situation is described by PQ in the figure B. After the contact is made, the output member perfectly follows the input member. When there is a contact between the output member and the input member made, then the output member follows the input member, and this is illustrated by the line segment QR. This is when there is no contact, this is P and this is Q, and when after the contact is made, then it follows the direction QR. As the input motion is reversed, the contact between the input and output member is lost. When this is reversed, then it is lost, then the output motion takes place in the reverse direction until the input member has traveled to a distance 2h, and this is illustrated by R to S. After the input member establish the contact with the output member again, means in these positions the output member moves in the reverse direction segment from S to T. As the input motion is reversed, the output member is again at standstill for the segment till T to U, and then follows the input member again U to Q. So we also call the backlash is a double valued non-linearity, and that means why we call it double valued, because there are two types of movement. One is forward movement and another is backward movement, and it is also a memory type non-linearity. Then we are going to discuss about the describing function of backlash nonlinearity. So this is the figure, and from this figure we find out the input I. Here we take input as I equals to Im sin omega t and yt as follows. From here we can find out A1, and from here we get the value of A1. I am skipping the calculation here, but it is fully done in your note. And also after finding the value of A1, we find out the value of B1. And after finding out B1, we find out the GD j omega, okay, which is nothing but under root of A1 square plus B1 square by I tan inverse A1 by B1. What is capital I? Capital I is a maximum input, and B by 2 is a half backlash, and after taking that R is equivalent to B by 2 by I, we get that A1 is equals to 4 Ki by pi into R square minus R, and B1 is equals to Ki by pi into pi by 2 plus sin inverse 1 minus 2R plus 2R into 1 minus 2R into under root of 1 minus R by capital R. So from here we finally find out the value of the describing function of backlash, which is nothing but this equation. So today we are ending here, and in the next class we are going to discuss about the stability analysis. Thank you.